Okay, so what was the last commercial y'all have seen that made you really, really want to go buy something? Mine was a cheeseburger. It looked so good, but what about y'all?
Jack in the Box.
Jack in the Box? And what about toys? Anybody ever see a toy commercial that they like?
Yes.
What kind?
Barbie.
A Barbie? Okay. What about any action figures? What about a movie? Did anybody want to see a movie lately? See any previews?
Yes.
Which one?
Ouija.
What was that?
Ouija.
Ouija. That's pretty scary. I don't know if I'd want to see that, but it looks very scary. So, what about the movie or the preview made you want to see it?
It was interesting. Lots of colors. Exciting.
It looked exciting, yeah. It looked like it was a really thriller kind of movie, very intense. So today we're going to be talking about advertisements and how they affect people's choices on whether to buy them or not, or whether to go see a movie in this case. So right now we're going to show you a YouTube video of a product that we are going to be testing today in our experiment. Here it is.
Buster Racetrack. One demand. Watch it go.
How do they do that?
To go up the beanstalk and to the top. Keep rolling. Get knocked off. Curve. Flip and swerve. Flip the race. Wind your way up and roll your way down to win. Up the new Legends Rockets Racetrack to create the ultimate wacky track system. Out now for Moose.
Alright, so what did y'all think of that commercial?
It was funny.
So do y'all want to buy a Mighty Beam now?
No.
No, why not?
Because it was small.
It was small, but it did cool things though. Did you see it go up a ramp?
Yeah.
That looked cool. It made me want to buy it. Alright, so today we're going to test whether or not those claims that the Mighty Beam, what they did or what y'all saw in the commercial, we're going to test whether or not that is true. And to do that, we are going to answer our question of the day, which is, does the product really do what it shows in the commercial? Alright. Okay, so before we start our experiment, I want everybody to get out of their seat right now. Okay, so first thing we're going to do is jump. So everybody on the count of 3, we're going to jump. 1, 2, 3. Awesome. What made you fall back down?
Gravity.
Gravity. Awesome. Interesting fact. People, or I guess NBA players, they can only be in the air for 1 second. At least, well, this is all people, not necessarily NBA players, but only 1 second because of gravity. So gravity is the force that allows us to fall back down to the end. So now I want you all to get your hands, place them together like this, and start rubbing them together like you're about to make a fire. What is happening?
It's really hot.
It's getting hotter, right? And so this force is called friction, which is a resistance force, and it's caused when one object moves across the surface of another, or prevents that smooth motion from happening. Now I want y'all to pull out your chairs. Alright, now push them back in. That was an intense push. So what we just did was apply a force, and that is what we call a push and a pull. So you pulled your chairs out and then you pushed them back in. Alright, so during our Explore, we are going to be talking about these different forces and how we can use these forces to test our products. So before I give you all the materials, I want to go over a few safety rules. We are going to be working with a Mighty Beam, and so number 1 rule with all of our materials, we don't eat them, remember? Yes.
Real bean?
No, it's not a real bean, but even if it was, we don't eat our materials, right? So we're not going to be eating them, or we're not going to be throwing them either. Another thing, think like a scientist. Remember, always ask questions why. Keep wondering why things work the way they do. And last but not least, our attention signal, which is hook 'em.
Horns.
Horns. Awesome. Okay, so now my partner is going to be passing out a worksheet, and on those worksheets, numbers 1 and 2, I want y'all to answer them together with your pair. Plus, I want y'all to answer them together with your partner. And what it's asking is, how can we replicate what we saw in the commercial? So think together with your partner, come up with a few examples, and we'll ask y'all to share. Okay, so now that we've talked to our partners and come up with a few examples of how to test our product, I want you all, we're going to be dealing with ramps, and we want to know the height of these ramps. So we are going to pass out some rulers. My partner is going to pass those out. And what I want y'all to do is measure the height of the ramp that is given to you. And my partner will be passing out the ramps as well. While y'all do that, we are going to take our own measurement as well, but we're not going to show y'all. So take your measurement, and then we'll look it over together as a class.
Alright, so how you use a ruler is you have to take into account this little space right here. So you have to be able to subtract this from the total you get of inches. And try to measure to the nearest 1/4 inch when you're measuring the ramp.
So once we find out those measurements, I want you all to fill that in on numbers 3 and 4 on your worksheets. My partner is going to be passing out job cards and some consumer reports that we are going to fill out together. Okay, so now that everybody has a job card, materials managers, come and get your Mighty Beam, and once you get it, go back to your group and start filling out your consumer report. Be careful.
Aaron, would you get describe some details how you test whether or not a commercial is true?
Buy it and play with it.
Liz, does your Mighty Beam look the same as in the commercial?
Yes.
Could you give some, was it the same color? Could you describe it?
It's small. It looked bigger in the commercial.
Bigger? Alright, probably because like in the commercial product display, they try to focus on Mighty Beam, so they might focus on it and make it bigger. Alright, so what was the length of your ramp? 22 inches? And what was the height of your Mighty Beam?
1¼ inch.
Alright. How long would Alright, how long would the ramp be if it were 8 times the measured length?
176 inches.
Alright, so we did some measuring already. So we're going to go over the forces that we talked about earlier in class. So what kind of forces did you guys see during the test of the Mighty Beams?
Magnetism.
Magnetism?
Gravity.
Any other ones?
Push and pull.
Push and pull? Alright. Can you roll a Mighty Beam on your hand like the commercial shows?
Kind of.
Alright. Does your Mighty Beam jump and dance?
If I make it.
Alright. What is the evidence for your opinion that the commercial is either accurate or not accurate?
It was hard to get up the ramp.
So it's
Like
not,
in the commercial, they made it look really easy.
do you think maybe using a stronger magnet would make it easier?
Maybe.
Alright. How would you change the advertisement if you could write a new one?
Make it more realistic. I would show the magnet that they use to make it go up the ramp.
Alright.
So now that we've tested our Mighty Beans, we are going to look at another product. One that is often seen around the house, and that is paper towels. So here on our document camera, we have two brands of paper towels. We have Boardwalk and Cisco. Both make the claim that they are very tough, they are long-lasting, not strong-lasting, and they are durable. Who thinks they know what durable means? Yes, you.
Strong.
Strong, exactly, yes. Durable means strong. So what we're going to be doing is testing the durability of these two products. So everybody should have both of these cups with each paper towel wrapped around the top. And so what I'm going to do is explain to y'all how our experiment is going to go. So we have both of our cups, and we are going to add rocks onto the very top of one of them. So we're going to do it one by one. So first I'll choose the Cisco brand, and I'm going to place the rocks on top. After I have my rocks set up, I'm going to add a pipette of water, just fill it, and I'm going to add 5 drops. So 1, 2, 3, 4, 5. Now I'm going to let it sit for 20 seconds. And so we'll count that out and we'll show a timer on the document camera when to do that. Okay, so remember, so we are adding 5 drops for every trial, and we're waiting a couple of seconds to see what happens to the paper towel. We're going to repeat that trial until the towel breaks, and we're going to count how many drops of water that we used in order for the towel to give in, to collapse. So, quick note though, when we're doing this experiment, remember we have to use the same amount of rocks for each type of paper towel. Why do you think we need to do this? Why should we use the same amount of rocks for each brand?
To test the durability.
To test the durability.
It's a control.
Yeah, it's a control. So what we're trying to see is not the amount of rocks that it takes, but the amount of water droplets. So we're going to leave the amount of rocks the same in each trial. Okay, so the materials manager, y'all can come up and collect your rocks, your pipette, and your cup of water. And if you need more, raise your hand and we will refill your cup. Alright, so now that we've tested our product of paper towels, which one do y'all think was the most durable? And you gotta give me a reason why.
The white one, because it took a lot of drops compared to the brown one.
Yeah, did you predict that one would be stronger or no?
Yes.
Awesome. Who made a prediction that came out wrong? And it's okay, it's not all of our predictions are always going to be right. Yes?
I predicted that the white one would win, but it was actually the brown one.
Okay, and how many drops of water did it take?
200.
200, that's a lot. Okay, so not everybody got the same results. Some had the brown paper towel being more durable than the other. Why do you all think that is? What could we have done in the experiment that might have affected that?
The size of the drops.
Yeah, the size of the water droplets, they could have been added to different areas on the cup or on the paper towel. The water droplets could have been bigger than the water droplets on the other paper towel. So a lot of it could be human error, and that is our mistake, but what we try to do is we try to decrease that human error so that our experiments will give us true results. Alright, good job today on the exploration. I hope everybody had a lot of fun. And now we're going to do our show off what you know. It's the one time in class I'll allow y'all to show off. So go ahead and take out your pencils and put everything else away.
Alright, so we're going to go over show off what you know. So we're going to go over question number 1. Which of the following forces acted on the mighty beings during the first part of the experiment? What answer did you guys get? See? Correct. So gravity did affect how the mighty being would go up the ramp. And let's go over number 2. Why was it important to make sure that our rulers didn't have any extra space at the bottom? What answer did you guys get?
Hey!
Alright, so it is A, because if you don't take the little space to account, it could affect how many inches. It could add an inch or maybe even half an inch. Okay, we're going to go over number 3. And company performed lots of testing toys and recorded the number of hours they could withstand tough play. Which toy is the most durable or will last the longest?
B.
Toy B, correct. It did last the longest because it took 15 hours for it to, I guess, kind of wear out. And we're going to go over question number 4. Jason was watching Saturday morning cartoons and a commercial for a new remote control car came on. The commercial showed that the car climbing rocks and driving really fast. What should Jason do before he buys a new toy?
A.
B. C.
A is wrong. The correct answer is B. He should make sure to check the consumer report and do research so he gets all the facts that the toys actually work the way they should, not how the commercial shows it. Okay, we're going to go over the last question, which is number 5. If Jill has 274 mighty beans and Carly gives her 23 more for her birthday, but one is broken, how many working beans does Jill not have?
96.
Correct. So one of the toys doesn't work, which makes it 22 toys. 22 plus 274 is 296.